Hey guys, welcome to question MM299 of the Maths Methods Fortify study guide. Now, part of the graph of the function f of x equals x cos x is shown below. And part A is a 1 mark question and it says find the derivative of 2x sine x. Awesome. So, first things first is to say, let y equal 2x sine x. Now, how do we find the derivative of this? Well, in between here, there's a little times symbol, which means here we've got a product rule, yeah, because we've got our first function multiplied by a second function, which means we're going to let y equals u times v, where u equals 2x and v equals sine x, right? Our normal product rule says that dy dx is equal to u times dv dx plus v times du dx. So u is 2x, so 2x times dv dx, so the derivative of sine x is cos x, so we get times cos x, plus v, which is sine x, multiplied by du dx, derivative of this, which is 2, okay? So we get 2x cos x plus 2 sine x. That's our first and final mark. So that's part A done, guys. This should be pretty straightforward, but this leads into a bit more of a complex question next. So let's move on to part B. Part B is a 3 mark question. I'm just going to leave this here because we're going to need this for a second and then I'll rub it out. So part B says, hence, find the area of the shaded region in the diagram above. Awesome. So we don't have a CAS here, right? Which is why we had to do the first part first. So what we're doing now is integration by recognition, okay? So we can't, in methods, we can't find the integral of x cos x. We don't learn how to, unless we use integration by recognition. And what I mean by that is, we know that the derivative of 2x sine x is this, right? Which means that the antiderivative of this, so the antiderivative of 2x cos x plus 2 sine x equals 2x sine x, right? So before, in the previous part, we derived this to get this, which means we can antiderive this to get this, okay? Because we want to get the antiderivative, or the integral of x cos x, right? Which is this bit here. It's got a 2 in the front, but we can move that. But essentially, this is what we're going to do. So, we need to find the integral of x cos x first. So from here, this is actually our first mark, straight up. Recognizing that this is the first step in the process is our first mark. So what we're going to do now is we're actually going to separate these two integrals. So we're going to say that the integral of 2x cos x dx plus the integral of 2 sine x dx equals 2x sine x. Okay, so exactly the same line of working, we've just separated these two integrals because we want this by itself eventually. So in order to get this by itself, we're going to say 2x cos x dx. We're going to minus this to the other side. Okay, so we get equals 2x sine x minus the integral of 2 sine x dx. Cool. This 2 is a constant, so we're going to bring that out the front. So we get 2 times the integral of x cos x dx equals 2x sine x. Now, the integral of 2 sine x is 2 cos x. Oh, sorry, negative 2 cos x, right? So if we're taking that away, we get plus 2 cos x. Awesome. Now, from here, we can simply divide both sides by 2 to get rid of this 2, which means, actually, you know what? Because all these have 2's, I'm just going to cancel these. So, we now know that the integral of x cos x is x sine x plus cos x, okay? We couldn't do that before because we didn't know this. But now we've got that, right? So then we can actually find our area. So our area is going to be equal to the integral of this between these two x values. So from 3 pi on 4 to 4 pi on 3, x cos x dx, right? Now, because it's under the x-axis, we're going to need to make it negative, but I'm going to do that as our last step, okay? So I'll do that at the end. So this, okay, so I've just rubbed it out, but you've got it there. so this is equal to, because we know that the integral of this is equal to x sine x plus cos x, that's our integral, right? 4 pi on 3, 3 pi on 4, okay? So we found that this was the integral of this, which means that we just sub that into our area, okay? So now we can just evaluate this as we would a normal integral. If you're confused by any of this, just hit me up in the comments. I'll be able to answer any questions that you've got. This is our second mark for this question. And then from here, we can just start evaluating. So we get 4 pi on 3. So we're subbing this 4 pi on 3 to all of our x values. So sine of 4 pi on 3 plus cos of 4 pi on 3. And then minus 3 pi on 4, sine of 3 pi on 4, plus cos of 3 pi on 4. Awesome. From here, we end up getting 4 pi on 3 times negative root 3 on 2, which is this bit here, minus a half, minus 3 pi on 4 times root 2 on 2, so that's this bit here, minus negative root 2 on 2, which is this bit here. Awesome. Then from here we get 1 over 24. Now I'm skipping a few steps, but I'm sure you'll be able to kind of follow along with this. So negative 16 root 3 pi, minus 12 minus 9 root 2 pi, plus 12 root 2. So that's our area. But because our area is below our x-axis, so area is below axis, therefore our actual area is the negative version of this. So area equals negative 1 on 24, and then all of this again. So negative 16 root 3 pi, take 12, take 9 root 2 pi, plus 12 root 2, and that's it. So this is our third mark, guys. I know this is a little confusing. Integration by recognition is definitely something you should practice. I'm shooting this video a couple of weeks after the 2017 Maths Methods end of year exam, and a question like this was on it. Okay, so they like putting these in because students struggle with it. So if you can get really good at these, that's awesome. As always, guys, hit me up if you have any questions in the comments below. But otherwise, thank you for watching, and I'll see you in the next video.